Okay, in this lecture, we're going to study Chapter 9, Net Present Value and Other Investment Criteria. We're going to learn how firms evaluate or how firms should evaluate their potential investment projects. Evaluating investment projects is called capital budgeting decision. A firm can ask, what fixed assets should we buy? Or what investment project should we undertake? This all sounds like a very simple question, but there are many capital budgeting decision rules that have been proposed in practice. And we're going to learn some of the most important ones used by the firms. At the end of this lecture, we have to decide which capital budgeting decision rule we should use. To do that, we have to understand some of the properties that a good decision rule must have. A good decision rule must adjust for the time value of money and risk associated with the project. Ultimately, a good capital budgeting decision rule must provide information on whether or not we are creating value for the firm. The first capital budgeting decision rule we're going to study is based on net present value, or NPV for short. The NPV rule asks how much value is created from undertaking an investment. The NPV rule directly asks whether we're creating value for the firm. Given the initial cost of a project, CF0, which is a negative number representing cost or cash outflow. To compute NPV for the project, first we have to estimate the future cash flows. C1, C2, C3, etc. And we have to estimate the required return for the project. Then we can find the present value of the cash flows. So C1 over 1 plus R plus C2 over 1 plus R squared plus C3 over 1 plus R cubed, etc. And we subtract the initial cost of the investment. This is called net present value. It's called net present value because it calculates the present value of future cash flows net of the initial cost of the investment. Once we compute it, NPV for the project, the decision is very simple. We should accept the project if the project has a positive NPV, because in that case, we'll be creating value for the firm. If the project has a negative NPV, then we'll be destroying value for the firm if we were to undertake it. So we should reject the project. As you can see, the NPV rule addresses all the right questions. It adjusts for the time value of money, it adjusts for the risk, and it directly tells us whether we are creating value for the firm. Let's look at an example. You're reviewing a new project and have estimated the following cash flows. The initial cost is $165,000. and has the following the cash flows for the next 3 years. So what is the NPV for this project if the required return is 12%? So NPV is negative 165,000 plus the present value of the first year cash flow, 63,120 over 1 plus 0.12 plus 70,800 over 1 plus 0.12 squared plus 91,080 over 1 plus 0.12 cubed. So if you compute this, you should get $12,627.41. So that's the NPV for this project. And at a required return of 12%, we should accept this project. So next capital budgeting decision rule we're going to study is based on the payback period. So this rule asks how long it takes to get the initial cost back in a nominal sense. In other words, how long does it take for the project to pay itself back? The computation is very simple. First, we have to estimate future cash flows as before. Then we subtract future cash flows from the initial cost until the initial investment has been recovered. We accept the project if the payback period is less than some specified period of time. Let's look at our example. This is the same example as before. We want to compute the payback period for this project. The initial cost of the project is $165,000. That's how much we need to recover. In the first year, we can recover this much. We can subtract that from here. Then we'll get $101,880 to recover. So in the second year, we'll recover this much. We can subtract that from the remaining cost. So after 2 years, we'll have $31,080 left to recover. So if you compare this to the third year cash flow, you see that third year cash flow is much more than what has been left to recover. So it's not going to take an entire year. It will take only a fraction of an year. When we compute the payback period, we're going to assume that cash flows are generated evenly throughout the year. So if we compare these two numbers, then we will get 0.34. So the payback period is 2.34 and 4 years. So if we impose a payback cutoff of 2 years, what should we do? Based on the payback period rule, we should reject the project because it takes longer than what we consider to be acceptable. As you can see here, different decision rules lead to different decisions. Based on the NPV rule, we should accept the project. But based on the payback period rule, we should reject the project. Then what should we do? Well, whenever there's a conflict, we must follow the NPV rule because other capital budgeting decision rules may have some serious problems. The biggest advantage of the payback period rule is that it's very simple and easy to understand, so many people like it. But it has many issues. One of the biggest issues is that the payback period rule completely ignores the time value of money. So it treats later money equally as earlier money, and we have learned that earlier money is worth more than later money. Also, the payback period rule requires an arbitrary cutoff point to make a decision. So what if the project generates lots of cash flows just after the cutoff date? The payback period rule will completely ignore that. Because of this, the payback period rule is biased against long-term projects, such as R&D. There's a related capital budgeting decision rule designed to fix one of the most important disadvantages of the payback period rule. This is based on discounted payback period. The discounted payback period rule, as the name implies, is calculated using the discounted cash flows. So it asks how long it takes for project to pay back on a discounted basis rather than in a nominal sense. Let's go back to our example. So what is the discounted payback period if the discount rate is 12%? Given the cash flows, first we have to discount these cash flows at our discount rate. So let's do that first. The first year cash flows is $63,120, and we discount this at 12%. So the present value is $56,357.14. So that's the present value of the first year cash flow. The second year cash flow is $70,800. So we discount this at 12% twice. So that's the present value of the second year cash flow. Then we'll get $56,441.33. In the third year, the cash flow is $91,080. So we discount this at 12%, 3 times, to get the present value, which is $64,828.94. So these are the present values of the cash flows. Once we computed the present values, we can proceed as before. So the initial cost is $165,000. So that's how much we need to recover. After 1 year, we can recover this much on a discounted basis. Then we'll get $108,642.86 left to recover after the first year. During the second year, we can recover this much. So we'll have $52,201.53 left to recover. So if you compare the remaining cost to the third year cash flow, then you see that we will need only a fraction of a year. So we compare these two numbers. We'll get 0.81. So discounted payback period is 2 years, 2.81 years. So as you can see here, discounted payback period rule fixes one of the most important disadvantages of payback period rule, but it still has all the same disadvantages as the payback period rule. So next capital budgeting decision rule that we're going to study is based on the internal rate of return, or IRR for short. The IRR rule is very popular in practice and the biggest competitor to the NPV rule. And actually, they are very closely related to each other. The IRR is a return that makes the NPV equal to 0. The IRR decision rule is to accept the project if the IRR is greater than the required return, meaning that the project is earning more than what is required to make up for the cost to the investors. Let's go back to our example. What is the IRR for this project? First, we have to compute the NPV using unknown return R. So NPV is negative 165,000 plus 63,120 over 1 plus R plus 70,800 over 1 plus R squared plus 91,080 over 1 plus R cubed. And the IRR is the solution to this problem. It's a return that makes NPV equal to 0. So we can solve for R, find the IRR. So we can find the IRR using the trial and error process that we've learned before, or we can use a financial calculator. So we're going to use cash flow key here. And before we do any problem, we want to clear the memory. So press second and clear work key here. Then there's nothing here. Then we can input the numbers. So CF0 is the initial cost, so 165,000 negative, and press enter. Then press down arrow to input the next variable, the cash flow 1. The C1 is 63,120. Press enter to input and press down arrow. Do you see F01? That's the frequency of the cash flow. We have this cash flow only once, so we accept the default setting, which is set to 1. Then we can move on to the next cash flow. So C2 is 70,800. Can press enter. So that's this cash flow. The frequency of this cash flow is only once. Then we can move on to the next cash flow, C3. So we input 91,080 and press enter. Then we have the inputted all the cash flows. Then we move on to find IRR. Then press IRR key here, and then press compute key here. Then we will get the IRR of 16.13%. Once we've computed the IRR, we can compare the internal rate of return with the required return for the project. This is because IRR is greater than 12%, which is a required rate of return. We should accept the project. The IRR is one of the most popular capital budgeting decision rules in practice. So it has several obvious advantages. First, knowing a return is very intuitively appealing, and it is very easy to communicate with someone who doesn't know all the estimation details. So you can simply say, this project has a return of 10%, and everyone will understand. And if the IRR is high enough, We may not even need to estimate a required return, which is often very difficult to estimate. Because if the IRR is high enough, then we will easily pass the threshold level of any required return that we may come up with. On top of this, the NPV and IRR will generally lead to the same decision anyway. But there are two important exceptions. The first exception is when we have mutually exclusive projects, meaning that if we choose one project, we cannot choose the other, so we have to pick one. For instance, if we were to use our space for clothing store, then we cannot use it for the restaurant at the same time. The second exception is when we have non-conventional cash flows. So what is non-conventional cash flows? Well, we have to understand conventional cash flows first. So what is considered to be conventional? Where conventional cash flows typically begin with negative cash flow, which is the initial cost of the investment. And this is followed by positive cash flows. So the sign of the cash flows change only once. Non-conventional cash flows, on the other hand, so this is non-conventional. So again, cash flow begins with a negative number and followed by a positive number. And maybe the sign of the cash flow change again. So for non-conventional cash flow signs change more than once. For example, we may have a negative final cash flow like this. Maybe because there is some cleanup cost for the project. In these two cases, NPV and IRR may lead to different decisions. Whenever there's a conflict between NPV and IRR, or another decision rule for that matter, we have to use NPV always. Let's look at an example of mutually exclusive projects. Consider these two projects, and these projects are mutually exclusive, meaning that if you accept project A, then we have to reject project B and vice versa. So what is the IRR for each of these projects? So if we compute the IRRs, we'll get the IRR for project A is 20.14%. And for project B, we'll get 18 points and 18.33%. So project A has a higher IRR. So based on the IRR rule, which project should we accept? Where the higher the IRR, the better. So we may be inclined to accepting project A. The question is, will this be a correct decision? The answer depends on the required rate of return. So let's say the required return is 12% for both projects. Here we use the same discount rate because both projects have similar level of risk. So at 12% required return, if we compute NPV for project A, we will get $4,406.74. And for project B, NPV is equal to $4,982.18. So project B has a higher NPV than project A, so we should accept project B instead of project A if we require a return of 12% for both projects. So IRR and NPV lead to different decisions, and we should always use NPV rule if there is a conflict. How about at other rates of required return? We can draw an NPV profiles for both projects at different discount rates. So we have required rate of return on the x-axis and NPV on the y-axis. Because NPVs and discount rates, they move in opposite directions, we'll have a downward sloping curve. So for project A, we might have an NPV profile like this. It will cross the x-axis at 20.14%, which is the IRR for project A. And for project B, so that's for project A. Project B might look like this, has a profile, NPV profile that looks like this. And project B will cross the x-axis at 18.3%, which is the IRR for project B. And these two curves will cross at this point, and we call that crossover rate. So if the required rate of return is below this crossover rate, so if we are here, then we should always accept project B. However, if the rate of return, required rate of return is greater than this crossover rate, then we must accept project A as long as it has a positive NPV. Then how do we compute this crossover rate? We first have to compute the differences in cash flows between two projects. So we can do the A minus B or B minus A. It doesn't really matter because we'll get the same answer anyway. So we do is B minus A. The cash flows, the differences in cash flows between project B and project A. So at year 0, the B minus A is 0. And in year 1, then the difference in cash flows is 4650 minus 15,100. So if you compute this, then it will be negative 10,450. And in year 2, the difference between the cash flows is negative 2,850. And year 3, the difference in cash flows is 63 and 50. And in year 4, the difference is 12,050. So that's the differences in cash flows between two projects. Specifically, cash flow from B minus cash flow from A. Then we can compute the IRR for these cash flows. We'll do CF, we clear work, and CF0 is 0. Then cash flow 1 is 10,450 negative. Press enter. And F1 is 1 by default. Cash flow for year 2 is 2,850 negative. Press enter. And third year cash flow is 6350, so that's positive number. So press enter. Cash flow for year 4 is 12,050. Press enter. And go to IRR. So press IRR and compute. The IRR is 14.25%. So this is crossover rate. So in this case, crossover rate is 14.25%. Okay, so that's all I want to talk about in this lecture. Thank you for watching. I'll see you next class.